all my followers. I hope you are preparing well. And here is a standard model problem which was picked up from rearrangement reactions part 1 online exam which was conducted on test series of chemmasters.online institute. So here by just analyzing this problem one can get a complete information about a rearrangement reaction. Okay, right. Each and every question will be designed to meet basics to advanced concepts of chemistry to get huge success in various competitive examinations of chemistry on our online test series of chemmasters.online. If you are interested, you can register and practice more and more a standard online test series to get huge success. Okay, now just look at the given problem. Here, by just looking at carboxylic acid functional group, okay, and HN3, that is hydrozoic acid, along with H2SO4. By this combination, most of us, more than 90% of students, easily known or knows that the reaction is a Schmidt rearrangement reaction. Okay, Schmidt rearrangement reaction. And more than 90% of aspirants just choose the first option as the answer because all of them just know that only carboxylic acid functional group reacts in Schmidt rearrangement and produces one carbon less amine. Okay, primary amine as the product. So it is absolutely wrong because here all other functional groups, the carbonyl group here as we given aldehyde and also ketone and tertiary alcohol, even alkene also react in Schmidt rearrangement reaction conditions. Okay, so it is surprising for most of aspirants who are watching this video because most of them just know that only carboxylic acid functional group react here and produces one carbon less amine as the product. And when I post this problem on social media, most of them given first option is the correct answer. Okay, it's wrong. Now try to look at the basic mechanism involved in Schmidt rearrangement. So here just take general carboxylic acid and reacting in acidic conditions. So lone pair of electrons on hydroxy and attack on proton in a next step. So here is a formation of OH2 plus. Okay, due to presence of positive charge on more electronegative oxygen, the bond between carbon and oxygen cleaves to compensate positive charge on oxygen. By that it loses water, and here is the formation of acyl carbocation. Okay, right. In your next step, here we have hydrozoic acid. So just try to expand its structure. So central nitrogen with positive charge because of it is with 4 bonds, and the terminal here we can say this nitrogen with negative charge. Okay, and hydrogen with positive charge here. So the negative charge on this nitrogen attack on this electrophilic carbon. Now draw the next step, or C double bond O. Here N triple bond N plus. Okay, right. In the next step, the lone pair of electrons on nitrogen moves here, and this alkyl migrate onto electron deficient nitrogen. Okay, we know that Schmidt rearrangement involves electron deficient nitrogen. Okay, right. Now after this, the loss of the stable molecule N2 takes place and produces or So here just draw the next step as or N double bond C double bond O. We can call it as isocyanate. Okay, isocyanate. Now, from that acidic reaction conditions, water molecule act as nucleophile and attack on this carbon. Now, the bond electrons first moves on to oxygen because of it is more electronegative. Then, so further just rearranging the electrons, nitrogen gets electrons here. Now, we can say just draw the next step as like this, or so by taking up the proton from the reaction condition, so the negative charge on nitrogen attack on this proton. Okay, so here we can say A or NH, and here C double bond O, OH. Okay, in the next step, loss of carbon dioxide takes place, and this negative charge attack on this proton and produces RNH2. That is, primary amine is produced from this carboxylic acid reactant by the loss of one carbon, because one carbon is losing as carbon dioxide. Okay, so this is the generalized mechanism for Schmidt rearrangement, which simply involves isocyanate and electron deficient nitrogen. Okay, and it is known by most of the students and aspirants. Now, how the reaction mechanism is observed on all these three functional groups. Okay, now we can see them. Right. So if you take aldehyde or C double bond OH, in your first step, the lone pair of electrons on carbonyl oxygen attack on proton. So here you can draw OH, H, and here is the positive charge on it. This carbon just looking like more electrophilic, because oxygen with positive charge, this bonded electrons always drags onto this oxygen. That's why. So hydrozoic acid, nitrogen easily attack on this carbon. Okay. Now you can draw the next step as like this. So by taking up the proton from the reaction conditions, here is a formation of OH, nitrogen, N triple bond N plus. Okay, right. In further step, by taking up the proton from reaction conditions, so water molecule cleaves from it. Now H here, nitrogen. So it takes place whenever the lone pair of electrons nitrogen moves here. Okay, and in this condition, double bond here on the nitrogen. Now N triple bond N plus. Okay, so alkyl migrates onto this nitrogen to eliminate the stable leaving group N2. Right here, C double bond N R. Here carbon with positive charge. Right. So in a next step, water molecule from that reaction medium, just acting as nucleophile, attack on this carbocation. Okay, draw the next step here, N and double bond C. So just OH, just drawing it. Okay, and one of the proton just cleaves, and okay, so this double bond just bond between oxygen and hydrogen cleaves, and double bond moves on to nitrogen. Here, by taking up this proton by this nitrogen, we can write NH or C double bond OH. So this is the product can be seen in this Schmidt rearrangement. Okay, right. And just check the options here. You can see the second aldehyde is converted to NHCHO. Okay, these two are done. Now, just look at the third one. That is tertiary alcohol. Okay, so tertiary alcohol, by just reacting with proton and by losing water molecule, here is a formation of tertiary carbocation Now hydrozoic acid attack on this carbocation. So here N, so just write down the complete structure. In the next step, the lone pair of electrons on nitrogen moves here and alkyl group migrates onto nitrogen and eliminates this stable N2 from it. Okay, now here you can draw next step as like this, double bond NR. Okay, so this is the next step can be seen for that tertiary alcohol. Okay, now you can see in the third one, this the product the correct, this is the correct rearrangement of this tertiary alcohol. Okay, now just look at the fourth one, how alkene can react with can react in Schmidt rearrangement. Listen carefully and just take the mechanism carefully. Okay, right. Now, so just draw the substituted alkene here. So just take the general substituted alkene. In a first step, we know that alkene act as nucleophile. So the alkene double bond electrons attack on proton, and in that case here is a formation of carbocation, which is also tertiary carbocation. Now hydrozoic acid attack on it. Okay, so here N triple bond N plus, and then the lone pair of electrons on this nitrogen. Okay, so moves here. So here is the loss of methyl group, sorry, CH3 minus methyl carbanion. Okay, now double bond N is there. So double lone pair of electrons on nitrogen. So triple bond here with nitrogen with positive charge. In the next step, oh, sorry, just wait. So here not with here it is positive charge. Okay, nitrogen with positive charge. Now the one of the alkyl branch, here we have methyl, here we have bulk group. Okay, that is secondary. So secondary alkyl group migrate onto this nitrogen and just eliminate this stable N2 takes place. Okay, and from that it produces CH3 and double bond N. So here is a carbocation, and which is attacked by this CH3 minus here. Okay, and it produces the branch like this, double bond N. So this is the rearrangement product we can see from this tetra substituted alkene. Now just check the fourth product, where you can see we have, that means rearrangement is observed, but 3 alkyl groups are just substituted on 1 carbon. Okay, but in the product you can see, or you must have the general mechanism with like this. So here you can see a double bond. Okay, so fourth option is the wrong one, because that is not the correct rearrangement. So third option is the correct answer for the given problem. But alkene can also involve in Schmidt rearrangement reaction. Just note these points. Okay, so from this problem you have linked that not only carboxylic acid, aldehyde, ketone, tertiary alcohol, and a substituted alkene also involves in Schmidt rearrangement and produces rearranged products. Okay, if you like this video, please click on like button and get subscription and channel, and also just look at just visit chemmasters.online website and join the best concept oriented courses and practice the standard online test series to get huge success. Thank you very much.